Okay, everybody, we're being recorded. Just on my private channel, I'll post this video to our course so everybody can see it, if you want to. But but basically, today we're going to cover flowcharting, specifically flowgorithm. So how are we going to get into flowgorithm? We got to navigate through this Byzantine maze. We go to the C drive, program files, flowgorithm. Double click on the executable, and after 4 easy clicks, you're up and running with flowgorithm. Yeah, I know it's a thing. So, some of the things that we learn about in programming that you might not have ever heard about before you took this course, one of them is the modulo operation. The modulo operation is the percent sign, right? So it's one of the first things you learn in computer science. Another thing you learn about is data types. Integers are not the same as real numbers, for example, in a computer. Booleans are values. True and false is actually values you can assign to a variable. Variables are things. So I just want to we've covered it already, but I kind of want to recap it. And if there's any loose ends, anybody who has any questions, like, oh my gosh, when that final exam question comes up, I'm not going to know how to answer it. Well, I want to answer it now. No, if you listen to a course, there's going to be one or two things you forgot. They might seem easy, but just don't let it slip by. Just stick it in your mind. What was that again? Ask it. So let's start off with modulo operation. So the modulo operation is it's like add, subtract, multiply, divide, right? But they shouldn't even call it modulo. I'm not even going to call it modulo anymore. I'm going to call it remainder operation, because then you'll remember it, right? We don't speak Latin, right? The modulus is the remainder. I don't know if it's a Latin term for it, but it's definitely, it could be Greek actually. I'm not sure. But anyway, it's just the remainder after you divide. So computers don't really divide the same way human beings divide. They do long division. They divide. They divide, and you can't have an infinite number of numbers like 3.33333. It can't go on forever. It has to end at some point. Computer can't go on forever. We can theoretically think, oh yeah, this is forever. Okay, there's no forever to a computer. It ends at some point. At some point, it's 3333, that's zeros. So they use this remainder operation, and so we have to know how to talk to the computers. We got to use this remainder operation. That's what this percentage. Let's talk about that first and foremost. So I'm going to output the remainder of. Can I make this bigger? I guess I can make this bigger. I'll say 10 divided by 3. 10 divided by 3. If I print this out, it gives me 3.3333333, right? Why does it do that? Because even though 10 is an integer and 3 is an integer, when it does the divide, it assumes, if you don't specify what the data type is, that it wants it to be a real number. But if I go and I make this, if I declare this variable, and I'll declare this variable to be just n, I'll use n for an integer and r for a real. And then I'm going to assign this 10 divided by 3. So n gets 10 divided by 3. And when I say integer n, that means that only the only number that can go inside of n has got to be an integer. There ain't going to be no 0.33. That's not going to happen. If you give it that, it's only going to take the integer part of the number. So now if I say output n, what am I going to get? No, it's not going to get an error. You get 3. Yeah. Yeah. Well, we'll let you decide whether that's an error. Is it a bug or a feature? Right? It's a property of almost every programming language. You're going to have integers. You're going to have real numbers. JavaScript doesn't. They have just numbers. But there's a lot of languages. Most languages have integers or numbers. And so it's only going to get the 3. Well, what if I say n gets uh, 0.9999, all these nines. Then what's going to happen? Is it going to round up to 1? No, it's just going to give us 0. Why? Because 0 is the integer part of this. I don't make the rules. That's just how it is. It's integer division. So what if I say, what if I want to have, let's suppose that I have, I'll give myself two other numbers. I'll give myself a x and a y. So now I've got x and y, and I'll say x gets 24, and I'll say y gets 6. No, I'll say y gets 5. And if x is an integer and y is an integer, if I say n gets x divided by y, what's n going to be? Well, if x was 25, 25 divided by 5 is what? 5. 25 divided by 5 is 5. But you're right. The answer is going to be 4 because it isn't quite 25, right? So if I output n now, it's going to say 4. But what if I want to find out what was left over? What was the remainder? Set? Well, I didn't really make an R, but I'll output. I mean, I'll just say output, and it'll be x mod y. What's x mod y? 4 also, right? Here, I'll make this 23. So now x mod y is 3. Is there any way to make that bigger? Oh yeah, plus. Here we go. So so x mod y is 3, but x divided by y is 4. Or sorry, well, x divided by y is 4, right? Because basically 20 and then there's 3. So the idea of this modulo, of this remainder operation, it's treated just like any other add, subtract, multiply, divide. It actually has the same order of precedence as division and multiplication. So all right, so you guys feel comfortable with the modulus operator? Let's try this around the room. I'll go and do some exercises here. Let's try it. Jeff, you feel comfortable with it? All right, so let's do 100 mod 3. What's that? 1. Right on. How about it? Juwan, you want to try one? How about let's say 11 mod 5. 1. Yep. How about Mike? You want to try? Let's try 36 mod 6. 0. Right on. How about Yojin? Yeah. How about let's try 23 mod 4. 23 mod 4 is 3, right? Sorry. Okay, you guys got it. So you get the idea. So I could fire away as many mods as you want. Now one of the cool things about this, of course, is you can use this modulo operation, this remainder operation, to tell whether numbers have certain properties, like for example, if they're even or not, right? We tried all that, right? So like, Kendall, you want to try that? If I want to tell if a number's even, I'll just say some number n. I want to know if it's even. What do I say? Mod 2. N mod 2. If it's even, it's going to be n mod 2 is going to be, if it's even, if n's even. No, it's going to be 0. Yeah, because you already got the hard part. The easy part's the hard. So basically, if I want to tell if it's even, if I want to tell if it's odd, I just do mod 1. Now, if I want to say if it's divisible by 3, I can say mod 3. divisible by 7 evenly, mod 7, right? Now you asked about binary. Could I do this with binary? Absolutely. What if I want to know if it's evenly divisible by 10? N mod 10, right? So N mod 10 equals 0 is going to tell me whether it's evenly divisible by 10. Hey, Julian, did you have a question? I know. I was thinking. I was thinking 23 divided by 4 is 5, right? But it's 23 mod 4. Yochin's smarter than we are. That's why. Because what's left over after? What's the remainder? Remember, this is a remainder operation. What's left over after you divide it? So what's weird about it is the modulo operation doesn't care what the division is; it only cares what the remainder is. I know it's like it's hard to get like into the zone on that operation, but that's what it is. Now the other interesting thing about this is we talked about bases, and this goes back to binary, but just if I wanted to say if it was a base 2 number, I could say any number base 2 mod 10 would tell me if it was even. How can I get the last 2 digits of a number that's greater than 100? I can say n mod 100. It's going to give me the last two digits of that number. So there's a lot of this goes back to the numbers, how you can play with numbers. We didn't really get into all that stuff, but you wonder why am I spending all this time on the modulo operation, the remainder operation, because we use it a freaking heck of a lot in computer science, and almost nobody else uses it. Nobody else, as far as I know, there's no other application where it's really commonplace. In pure math, they call it congruence, but it does happen, but it's not very common. Okay, so if I threw a whole bunch of modulus problems at you, you guys sounds like you can handle them. Terrific. Let's see what we had. I'm gonna get. So now the modulo operation is designed to work with a specific data type, the integer. So when we talk about numbers, we usually start off with integers when we're talking in computer science. And then we just pretend that real numbers don't exist for a while, and then we throw real numbers at you, and then the integer operations. Well, wait, what's modular 1.5? Doesn't make any sense because it's got to be an integer for that congruence to take place. So we talked about integers. I think we all know what an integer is. It's just a whole number, positive or negative, right? But we also have the concept of a real number. I'll say integer and real. And in computer science, we call them sometimes floating point or floats. And maybe for those of you who have been trying the caddis problems, you'll see where it says double. That's what a double is. So in computer science, we have ints and we also have longs. An int is a normal sized integer. A long is a really, really, really big integer. There's actually another one called big int, which is an arbitrarily long integer. But no matter what it is, in is that real life? Is math real life? No, math is not real life. In the fantasy world of mathematics, there's no mathematicians here, right? Good. You could have an infinitely long integer, right? You could just have integers that go on and on and on forever. But no matter how powerful your computer is, your integer is not going to be infinitely long. You'll run out of memory. Something will happen. You can't just keep on saying 1, 2, 5, 7, 8, 3, 4, 6, 7. It's going to run out of space, and it's going to just stop. So we have limits. So ints are a certain size, long are a certain size, big ints are very, very, very big, but still have limits. Floating point numbers are, let's just call them normal size real numbers, 1.5, 12.7, 1,000.12346. Doubles are longer. Why do we have floats and doubles? And why do we have ints and longs? Save memory. It's always a balance between more precision and waste more memory, or less precision and waste less memory. That's why we have these things. But you guys don't have to worry about that. All you guys got to worry about is integer and real. So let's take a program. I'll show you kind of a cool program. How many times do you think you can divide the number 1 in half before the computer freaks out? I'll go to my if I go to my M drive. I think I saved it there. There we go. I did svsu.edu/gpcourser/ sorry, tilde gpcourser. And I want to say /cs105. I created one called division.fprg. Link is not save your downloads. I thought if I, oh, that's right. It won't open with. Oh, great. Yeah, discard it. Downloads. Desktop. There we go. Yeah, that's not what it's called. What do I call it? Well, let's just make the thing. So let's just. I'll just make. I'll make a brand new program here. So I'm going to take this. I'm going to take the number 1. I'm going to divide it as many times as I want to, and I'm going to make a real. So I'm going to declare this as a real. Sorry. It's going to be a real number. And it's going to be r. And I'm going to initialize it by saying r equals 1. But of course, it's really 1.000, right? And then I'm going to divide it and divide it and divide it until it can't be divided anymore. So what I'm going to do is I'm just going to loop until r does not. Sorry, I'm going to loop while r does not equal r divided by 2. Because at the end of this loop, r will equal r divided by 2. It can't divide it any further. It'll either be 0 or 0.0001, right? And then so I'm just going to say, and I'm going to assign r gets r divided by 2. Now this time it's not integer division; it's real division, and it's quite literally real number division, real division, right? Not fake division. There's real versus integer, and there's real versus fake. This is both real. So now the problem is I want to find out. Yes. So when I say while, like while, it'll say while what? Well, while r does not equal r divided by 2. If I put r equals 1 and I say r divided by 2, it'll give me 0.5. 1 does not equal 0.5, so it'll keep on going it because r does not equal r divided by 2. But if I get down to a really small number, the computer can't handle any smaller. Eventually, it'll be so small that the computer can't tell the difference between r and r divided by 2. So then it'll stop because they are equal. So what's really weird about this? So if I said while r equals, if I said while r equals r divided by 2, it doesn't. It'll never go through the loop, right? So it's kind of like the not. This. We'll get into booleans in a minute, but it's kind of like there's things like they'll say. I remember when I was in Korea, I would ask kids, hey, you don't want to go to the principal, do you? And they'll say, yes. I say, you want to go to the principal? No, I don't want to. Yes, I don't want to go. But they were right, and I was wrong because the English language isn't correct. You don't want to go to the principal, do you? Yes, I don't want to. We say, no, I don't want to. It's twisty, right? Anyway, with computers, you got to be super specific about the thing. So if they're not equal, then I want a loop. They are equal, I want to bounce out of the loop. So I have to say while they are not equal. All right, so now the problem here is, how do I know how many times I looped? How do I know how many times I looped? I have to pop an accumulator in there. I have to put a variable in there, and this one's going to be an integer. So I have to declare an integer, and I'll call this, a lot of times we'll call this n or whatever it is, but it'll be count maybe or something, whatever you want. And then you have to initialize it with 0. Count gets 0. This right here is a fundamental concept in computer science too, is when you go to loops, is just the idea of setting up an accumulator. It could be a count, it could be an average, it could be a max, a min, it could be any number of things, right? We'll talk about that more in a minute. But for this time, I'm going to do a count, and I'm going to pop in here. Every time it works through the loop, I'm going to count one more time. I'm going to add this up. So it's going to be count gets count plus 1. Count plus 1. So there's all kinds of things that mess up. You forget to create the counter, or you create the counter but you forget to initialize it, or you forget it says count equals 1. You forget to do this count gets count plus 1. It's count gets whatever the count was before plus 1 more. And then at the end, what do we print out? We print out the count. That's this right here is a classic accumulator loop. This is a classic loop, actually. This is the classic loop. So now, how many times do you think it'll go through before it slices it in half, slices it in half, slices it in half, and it can't slice anymore? And nobody knows, right? You ready? 1074. On my desktop in my office, it's 333. Why? Because different machines have different size numbers. So when you run this program, it does depend on the computer that you use, because we're talking about numerical precision here. How precise can your number be? So it's going to be 1 divided by 2 divided by 2 divided by 2 divided by 2, 1,074 times. You want to see what the number looks like? It's pretty weird. So I'll create another one called, I'll just call this one be old. This will be the old one. I'll call it yeah, let's call it old. So I'm going to create R, and I'm going to create old, which is the one before it, and then the old I'm going to assign old is going to be R, and here R gets R divided by 2, right? So if after I bounce out of this loop, R and R divided by 2 are the same value, because that's why it bounced out of the loop. But if I keep the 1 right before it, this is the number right before it that did get divided okay. Everything was fine. So this is the second smallest number that it can hold. That's the second biggest arrow I ever saw. All right, so if I print out the old, I'll just put ampersand, space, ampersand, and old. So now it's going to give me how many times did it go, and how small is that number? And it should be 0.000 something. Let's see what happens. It's different on different computers. 9.88 minus times 10 to the negative 324th. But if you divide that number by 2, it says forget it, I can't. I can't quite do it. You'd think, well, why not? Just do 4.5. You know, no, the space and memories can't handle that level of precision. It just doesn't have any spots to put it in. Anyway, you get the idea. So we have a real number. The real numbers are limited. So you can have numerical precision problems. So sometimes you'll use, you know, this integer division, or you'll use modular operation to do the file save as. Yes. People at pay grades way above mine have figured out how to organize the memory of computers, not just Intel ones, but other types of computer processing, to try to get numerical precision. And you know, there's all, the answer to your question is yes. There's certainly a way. A bunch of egg-headed people figured it out, but they make special devices for it, right? I mean, or they make special languages to handle it. There's actually different data structures. Like I'm using reals and ints, but I could use a big int. It could hold a lot. Or this would be real. This would be a super high precision double. You can do that, but if it's on a computer, if it's on a digital computer, eventually you're going to run out of numbers. These are limited. These are finite. The universe or our mental concept's infinite. I don't know if the universe is infinite or not. I really don't. But that's getting to be philosophical right there. But at some point, right? But I hope you at least see the you can go and say, wonder how small can it go? Well, that's how small it can go. You get anything smaller than that, you can't divide it by two. Not on this computer. All right. So let's talk about data types. Now, I will. We talked about integers and we talked about reals, but the other ones that we need to talk about are strings and booleans. So if I go in here and I create, let's say I create a number R, and it's a real, and then I create N, and it's going to be an integer. And if I assign and I initialize, I'll say N gets 5, and I'll say R gets 1.23. Oops. R gets 1.23. So what if I try to output N plus R? What's going to happen? Are N and R the same data type? No. Can I add a real and an integer together and get a real value? Is going to freak out. Oh, hey. Oh, it gave me a number. It gave me a number. All right, we're safe. The world is safe for humanity. Why does it do that? It does a thing called dynamic casting, or they call it type casting. It basically says if you're trying to add an integer to a real, you must want a real, because it's sure as hell you don't want an integer. That's an assumption. It's an assumption. It's a reasonable assumption, but you know, what if we did? What if we wanted an integer? We only wanted to add the integer values. Can anybody think of a way? Yeah. Well, we no, you can't. You can't really use the modulo operation on a real. Yeah. We could create a whole nother variable, or we could just add R to the integer variable we already have, right? So if I say output, if I say uh, instead of N gets 5, I'll say I'll also say N gets N plus R. And then I can output N. Now we've lost the 0.23 because N is an integer. Right? Remember, R was 1.23. So in other words, if I declare a variable N and it's an integer, it can't hold anything except an integer. If it's 1.99999, you're just going to get the 1. And so if I want to obtain the integer piece of a number, I just got to assign the real number to an integer, and it'll assume that you only want the integer part. That's a built-in assumption inside the language. Integer division, handling only the integer parts of numbers. This is an extremely common part of computer science. You got to know this stuff. Well, your life will be a lot easier in 116 if you know these things. And this is called the data type, and when you force something to be a certain data type, it's called casting. If you force it to be a certain data type because the computer assumes it, it's called dynamic casting. If it casts it on the fly. Have you ever heard of typecasting in movies? Typecasting. So like you're never going to see Hugh Grant and Clint Eastwood play the same character. Can you imagine Hugh Grant going out with like a pistol and like, make my day? That's not going to happen, right? Or if you see Clint Eastwood like with Julia Roberts, oh, how could I be such a silly guy? No, it's kind of, they're just different characters, right? They're just different characters. Well, you can think of real numbers and integers like different kind of characters. You can't put them in the same box. So anyway, typecasting, same word. All right. Good enough. We've got typecasting, data types. Oh yeah, we didn't do Booleans. Now let's talk about Booleans. Let's suppose I want to find out if my integer is odd. So here I'm going to get the user to enter an integer, and I'll say input n. So we've defined this integer n, and now I'm going to have the user enter the integer. How can I find out? I just want to print out odd if it's odd, even if it's even. Yep, if statement, brilliant. If, and what do I say? N mod 2 equals 0. If n mod 2 equals 0, then what? Even. Well, it's odd. So if I run this thing, 23, odd, 22, even, everything's cool. Yes. Oh. Flogorithm, it'll still work, but it's not not really the computer way. Was that what you're going to ask too? It'll work. A lot of people have made it work. I mean, I promise you that it will work. I don't know. I don't know that specific, but if you send me your program on MS Teams, I can look at instantaneously. Yeah, I mean, a lot of people have that one. It's one of those frustrating things. So the question I would have is, um, what's the data type of n? Integer. What n mod 2? Oh, tell me it's not. My recording's blowing. Hang on. Is it working? Shoot. Usually that means that the thing's looks like it's okay. So n mod 2. So what if n was 15? What's n mod 2 going to be? 1. Right. What if it's 16? What's n mod 2 going to be? 0. 0 and 1 are both integers. So the expression, we call it an expression when there's operations in there. N mod 2 is an expression. N is an integer, 2 is an integer, n mod 2 is an integer. N mod 2 is an integer. What if I said n mod 10? Let's suppose I say it's 15. What's n mod 10? 5, right? If n is 15, n mod 10 is going to be 5. It's going to be an integer. What's n minus 10? It's an integer, right? 5 if it's what's n times 10? It's an integer. N divided by 10 is not going to work, but you see, but basically the operations are integer operations. Okay, how about this 0 here? Is that 0? What's the data type of that 0? It's an integer. N's an integer, 2 is an integer, 0 is an integer, mod 2 is an integer. How about n mod 2 equals 0? That whole expression. Boolean. Now, here's a weird thing. Check it out. This is pretty funny. I'll create a variable in here, and I'll declare this variable to be a Boolean. I'm going to call it B. I usually call my Booleans B. And then I'm going to assign B is going to be, oh, come on. There we go. B is going to be n mod 2 equals 0. I have to put if B. Now, a lot of times you'll name your Boolean variables so that you can talk them out to people. So I'll say, I'll call this B, n is even, or even just is even. And so I'll say if n is even. Pretty wild, right? But it will work. It'll still work exactly the same way. So hang on. N is even. Oh, sorry, I didn't create that. So n is even is the name of the Boolean, and I do this thing, and I'll set 23 and this. Now, this right here will flat freak people out, right? Because what is n is even? How many possible values are there for n is even? If it's a Boolean, 2. What are they? True or false? So I can go here and I can do output n is even. Do, 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 do. So if I'll get rid of this, and I'll just get n, and then I don't even have to have this variable if I don't want to. I can just say print output this. So if I go like this, I put in 23, false. 22, true. I didn't need to go through all these if statements and diamond shapes and all these branches and all this sort of stuff. Is it even? Yep. Just print out the true or false word. Because I know it's twisty, right? So true and false, like if I say something, that's true, that's false. Well, in computers, that's a value, just like 5 and 26.1. True and false, the computer doesn't know the difference between true, false, 26.1, hello. They're all the same to a computer. Just, it's got to fit in my box, though. You got a string box, I'll put a string in there. You got an integer box, I'll put an integer in there. You got a Boolean box, I'll put a Boolean in there. Now, what do you think is going to happen if I create a Boolean variable and assign an integer to it? I'll create this B, and I'll make it a Boolean. And well, I'll leave it like this. I'll output B. So I create this Boolean B, and I'll get the input of n. I wonder if it'll take. Let's see what happens. It might not take it. Let's just try running it. I'll say 23. And it won't work. It protects it. But I'll create a an integer. and I'll assign b equals n, or yeah, b equals n. So whatever the user types in, um, so I'll create a Boolean variable. Actually, you know what? I'll do it just to make it simpler. Doesn't matter. This is for human. You create the variable, you get the value of the variable. You create the variable, and then you assign the variable as output the variable. So what this is saying is create this. We need to get n though, right? It's the other way around. We want to get n and we want to assign it to b. So we want to input n. Sorry. We're going to say we need input n. So what I'm doing is I'm creating an integer. I'm going to get that integer, and then I'm going to assign b to be n, and we're going to output b. Let's see if it works. No, it doesn't like it. In some languages, like JavaScript, 0 is false and every other number is true. But Flowcharting is its own language, so it doesn't really work. There's not automatic typecasting there. But in some languages, there is. All right, so okay, enough of that. So Boolean, oh, we didn't do strings yet. Strings are all, there's also dynamic typecasting, right? So if I have n and I want to output your number was n, if I try to concatenate a number to a string, what's going to happen? It turns the number into a string. It assumes that, hey, look, we can't turn a string into a number, but we can turn a number into a string. We assume that's what you meant. That does make it easier. So if I do this and I type in 23, it's going to do your number was 23. Again, that's dynamic casting. So what we just talked about just now was data types. I'll go back to this. Modular, integer, real, Boolean, and string. Are there any questions about strings? I mean, they're pretty much. I guess grabbing a certain character in a string might be something, but I don't think I'm going to have that in a final. Just the concept of a string. All right, nothing burning in your mind. Okay, enough about the data types then. Let's move on to. Yeah, I know that's kind of twisty, but I really want to focus on final exam study. So yeah, there are truthy and falsy and things like that. There's really any one of these subjects you could probably write a dissertation on it. Even something as simple as finding characters and strings and how that can be done, data storage and data types and everything. It's a rich field of research, but let's keep that offline because I don't want to. If people are panicked about the final and they're studying this video like the night before, I don't want them to be like talking about truthiness and falsiness. All right, so let's move on to the next topic, which is if statements. So call them decisions. An if and a nested if, and we'll also call it we'll call it a sequence of ifs. So we already tried. What if I want to find out if this number is odd or even? Right? I do an if statement and I create a Boolean in here and I'll say n mod 2 equals 0. That gives me, I can put whether or not that's even or not. So this is a simple, well, that's what we call a simple if. Now, what if I want to find out, let's suppose I have pass fail. No, better yet, I'll have ABC, whatever. We'll just do grades. You give me a score. Instead of n, I'm going to say score. And I want to print out the grade based on the score. 90 and above is an A, 80 and above is a B, and so on and so forth. How how would you do that if you're going to do a nested if? You can't do a simple if, right? Because there's too many different categories. A, B, C, D, E, F, right? Or say A, B, C, D, F, whatever it is. So how can I convert the score to the letter grade? Yeah. Yep. So score greater than or equal to 90. And we just do A, right? Now what if I want to do the B's? I got to do the same thing. And you can copy this, and you can paste it here. It gives you the whole branch. Just do 80. But this time it's a B. And by the same token, I can paste it again. 70. And this be a C. Now you might ask yourself, so this is what we call, and you say have a tree of all these nested ifs. These are called nested ifs. So this is an if statement, but within this if statement is another if statement. And the idea is, if it's greater than 90, it's going to be an A. And here it just says greater than 80. A lot of people say, well, if it's greater than 80 and less than 90, right? But you don't have to put and less than 90. It's already less than 90. We know it's less than 90 because it wouldn't have even got here if it wasn't less than 90. But it would not hurt. You can put in here and I can put and score is strictly less than 90. That won't change the processing at all. It's just unnecessary. When you have two statements like this inside, it's called a compound decision, compound if, and they can be as long as you want. But I'm going to show you another way that you can do this. I can put in here, if score is greater than 90, I can create this variable. I'll put this declare this a string. This grade, and not integer. We want this to be a string. And I'll and I'll put in here. I don't know. Usually you want to always initialize nothing. Now, as your score is greater than or equal to 90, I'm going to say string. Sorry about that. I'm not going to output anything. I'm going to say string gets A. Sorry, grade, which is a string, gets A. And then paste, paste, paste. I'm going to do, if it's greater than 90, give an A. If it's greater than 80, actually, we should do it the other way around, right? We should do, if it's greater than, we'll say if it's greater than 60. I will say whatever, 70. If it's greater than 70, it'll be a C. Greater than 80, it'll be a B. And that's not quite the right way. But it's greater than 90, be an A, and so forth. The problem is if it's less than that. But the idea is if this is a B. So if you put you can have these in sequence, and as long as it covers as long as it covers right, is it greater than 60, 70. This is 90. This should be 70, right? So we can start off with the grade is F, right? Start out with the grade is F, right? And if it's not greater than 70, it's going to stay an F. But if it's greater than 70, it's going to get a C. If it's greater than 80, it's going to get a B. If it's greater than 90, it's going to get an A. So this way, it's the same logic, but you don't have to have nested ifs. You have sequences of if statements to get the same logic, to get the same output. Of course, you have another variable here and everything, but I'm just showing you that you can sometimes you can break, like if you have these big monstrous nested if, you can sometimes break it into a bunch of sequences and it's a lot easier. But you have to be a little bit clever about it. So we have the simple if, we have the nested if, and we have the sequence of ifs. Straightforward, easy as pie. Okay. Great. Now let's do loops. So what if I want to do a loop and I want to put, let's suppose I have a whole bunch of grades. I'm going to type in some grades. I'm going to just type in like 20 grades or 20 scores, I should say, and I want to count how many of each grade there are. So at the end of the thing, I want to output I'll say A and A colon and I'll just say A, B, and C, right? A and space and B and space. Oh no. A. You guys can't see this too well. And B and C. Still the trouble. A and B and B and C. C. Let's just assume they're all A's, B's, and C's. I'm going to output A and A, B and B, C and C. And just to show you, I'll create this integers. There'll be integers A, B, and C. And I'll just assign all of them to be 0 right now so I can show you what it looks like. Assign A is 0. B is 0. And C is 0. And I want to type in, if I run this thing, it's just going to print out A0, B0, C0. But what I want to do is I want to type in, let's just say I want to type in 10 of them. I want to type in 10 different grades. I want to tell me how many of them are A's or how many of them are B's and how many of them are C's. And they'll all be between 70 and 100. How can I do that? Does anybody know how I can do that? With a loop, yeah.
You could do another variable.
Okay.
That would be the amount of time, like the amount of numbers you put in.
Okay. I'll create an integer n. And we'll grab that from the user. Actually, yeah, I'll just make it 10. How about that? I'll say n equals 10. So it's always going to be 10. Okay, so we're going to get 10 numbers from the user. That's going to be our loop. That's going to be our loop. You know, how many times we loop, right? All right, I'm digging that.
And you just do a for loop.
I love it. So we're going to do a for loop. For. We're going to need an iterator variable. Let's call it I, but I'll go back and declare it later. Start value 1 to n. So I like the for loop. I'm going to go ahead and create I, because you need to have whichever iteration of the loop it is, 1, 2, 3, 4, 5. And then what are we going to do?
We'll just copy all like the if statements from before.
I whacked them, so I'll put them all back in there. So let's say if, I'll use a compound one this time. If we have to get the input too, right? Get the user input. So we'll call this one score, and then we will get the score. Right, so we've got a loop, and we're going to loop through the. We grab the score, and we're going to put the score in a bucket. I guess it really doesn't even matter if it's a. So if the score is greater than 90 or greater than or equal to 90, it's going to be an A, right? This time, if score is greater than 90, what are we going to do? Huh? We're not going to output anything. We're going to count. So what we're doing is you can think of it like we have buckets. So I've got the A bucket, I've got the B bucket, and I've got the C bucket. I'm just gonna, at the end, I'm just going to print out how many of them was of each of those. So I'm going to grab a score, throw it in the bucket. Grab the score, throw it in the bucket. Well, hang on, Ben. I think you got it. You already did it. You've done enough. Let's get some, throw it around. How about Ardarsha? You want to try this? I want to grab. People are going to be typing scores into a program, and I want to throw the score into A, B, or C bucket. So I've got these buckets, A, B, and C. They're variables. They're integers. Right now there's 0, but I'm going to type in 10 numbers. 75, 96, 31. Who cares what it is, right? And if it's an A, I want to throw it into the A bucket. Huh? If it's true, what do I do? I'm just going to collect the numbers. Don't worry about it. I'm going to output. So right now it's just going to output 0, 0, 0. But however many of them there are, I'm going to output the count. This is the A count, the B count, and the C count. Huh? Well, here I'll do it. So I'm going to say A is going to get A plus 1. So before I got this score, A was 0. Now it's going to be 1. Why? Because I got one person who got an A. Yeah, we call them buckets. I know it's I'm not sure actually if that's even the right term today, but that's what we called them back when I did this. It's back in the ancient days when people had buckets. Anyway, so that's it. We just increment the count. And so I showed you before how we had that accumulator for just one thing, like a sum or something. But here you might have a whole bunch of accumulators going on at the same time in the same loop. So here I've incremented A. How about for B? What am I going to do? I could do a nested loop, or I could do a sequential loop, however I want to do it. Sometimes when you have these, you don't want the loop to get too deep. I'm gonna go ahead and I'm gonna use a compound one. I'm gonna copy this. I'm gonna paste it here. Yeah, correct, same thing. And I'm gonna say here if score is a greater than 80 and score is less than 90. So what's important here is this one is greater than or equal to 90, and this one is less than or equal to, sorry, greater than or equal to 80, but strictly less than 90. Mind you, these are all integers, so they're not going to be 0.999 or something like that. And then we do the same thing for the 70 range, 70 to 80. And so now we have A, B, and C buckets, right? And how many of them are we going to grab? 10 of them. So I'm going to grab 10 numbers. I'm going to loop 10 times through this thing. I'm going to grab 10 numbers, and however many A's I put in there, it's going to print at the end. It's going to print out how many A's, B's, and C's. Yes, sir. Oh, sorry, this has to be B's. Then it's not going to count it. There's no bucket for it. I don't have to have it in any bucket if I don't want. Okay. There's no law that says I have to have a bucket for anything. I could put in all zeros, and then it still comes out 0. But I do have to change, like for the A's, I got to increment A. For the B's, I got to increment B. And for the C's, I got to increment C. So that I got to change that. So if I run this thing, I'm going to type in 10 numbers. I'll just type in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's going to happen? It's going to give me all zeros because none of them are in those ranges. What if I run the same thing and I type in 100? No, I'll even type 1,000. 1,000, 1,000, 1,000. Go for a million, 1,000, 10,000, 1,000, 1,000, 1,000, 1,000. As long as it's over 90, it's an A. If I run this thing and I say, I'll say 75, 76, and 77, now I've got 3 C's, right? I'll do it 87, I got 1 B. And I'll do 123, 123, 123, 123. I've got 4 A's, and I'll do some zeros. Those aren't going to count. I've got 4 A's, 1 B, 3 C's. So a lot of times you can imagine when you're doing reports, you're writing reports for a company or whatever, you might collect up all kinds of how many people were from Michigan, how many people from California, how many people were from Oregon. You don't care about the ones from Wyoming, or whatever it is. You just collect these collectors and you just collect them up. Now, let's suppose I wanted to get the average of the ones who got A's. What was the average score of the people who got A's? You don't care about the other averages. You only care about the averages of the people who got A's.
The variable is for A divided by.
Luckily, we're dealing with all integers, so I'm going to create a thing called A sum, which is the sum of all the scores of the A's, right? Because we already have the count of all the scores, and if we sum all the scores what they were and then divide by the number, that'll give us the average of the A's. Do you see what I'm talking about here? You're going to do this in 116. That's why I'm doing this. It's like a real common thing. So now what I'm going to do is I'm going to collect up for just the A's. That's the only ones I care about. I'm going to collect out not only. Whoops! Did I just Control Z? Wait a second. I double clicked. That was kind of weird. So now I'm going to assign also. I'm going to say A sum gets A sum plus score, right? Whatever the score was. I also have to assign A sum. I have to initialize A sum to have 0. And so now I'm going to print out the average of the A's. I'll say average of A's was, it's going to be A sum divided by A. A is the count. So now I'm going to print out all those same counts that I got before, but I'm print out the average. Yeah.
You also, instead of typing it out like that, you just create like or assign something that
You could create a variable, but the problem is when you're computing the average, you can't like maintain the average as you go. You have to divide by the total numbers. So you kind of have to do it at the end anyway. So if it's some other calculations, it might be better to do a variable. That's actually good instincts. Sometimes it's better to do it at the end. Most of the time, sometimes there'll be a company standard for which way they want it done, but usually it's programmer's discretion because nobody really cares about how you did it. They only care about what the output is, usually. And these days, code is perishable like lettuce or something, You use the code and it serves a purpose and it goes away. In the old days, you'd write this perfectly efficient code and then it would last for a long, long time, but not anymore. Nowadays, you change the code all the time. So, but yeah, I mean, yes, you could. In the average case, this is actually the most accurate way of doing it is computing it at the end. So now if I want to run this thing, let's suppose that I'll have three 105s, 105, 105, 105. So we know the average of the A's is 105. I'm not going to put any more A's in here. I'll put some 75, 75, 77, oops, 76, and I'll put 34, whatever. I'll just put anything in here. Oops, I don't want 435. So the average of the A's, there's three A's, and the average of the A's was 105. So the reason I'm showing you this is I basically want you to see that you can take a simple idea like the if statement or the nested if, sequential if, or the accumulator, whatever, and you can make as many of them as you want. The reason programs get complicated is there's usually a lot of them. Okay, we have time for a couple of more. Functions. Let's make a function. No, this is right. Yeah, we want. Why does this not have function manager? Oh, is this the same as one you guys got? Oh no, here it is. Right here. Add function. Okay. Phew. So we're going to have a function, and we're going to call it grade of. Grade of is the name of the function. And then what we're going to have as a parameter is score. And the score is going to be an integer. And the return type is going to be a string. And the return variable will be grade. So I'll say, so what's going to happen is if I say grade of score, it's going to return whatever the letter is, string, that letter in it. So what this here means is there's already a variable called score in this function, integer score. And there's already returned a string of grade. It's already declared it for us. We can't delete this. I mean, we can, but the program won't run. So let's suppose it's going to be either an A or a B. How can I make this function? If it's more than 90, it's an A, otherwise it's a B. I have an input, I have a value called score. I'll show you. If score is greater than or equal to 90, then grade gets A. Otherwise, grade gets B. Can you guys see this okay? Let's just suppose it's let's suppose it's a. As a matter of fact, let's I'll even put this. I'll put better yet. I'll put 70. We'll do pass fail. This is the grade of thing. Now I'm going to go back to my main function, and I'm going to just get rid of all this stuff. We don't need all that. Now declare an integer, and it's going to have score. I don't have to call it score. I could call it a number, integer number, and then I can do output grade of n. I have to grab the number, of course. So I've declared an integer n. I get that value from the user, and then I print the grade of it. The grade, inside the grade function, it calls it score, but in the main module, it calls it n. Let's run it, see if it flies. So I'll put in 77. Let me check this out. Score, if score is less than 70, so yeah, kind of blew that one. That encourages a race to the bottom. Hey everybody, let's not do any work. Yoo-hoo, pass. There you go. So yeah, so let's try 77 again. Okay, that's teacher's problem right there. But there you go. So now, if you get, let's suppose, like, you might start off with, well, 90 is going to be an A and A is going to be, then you're going to say, no, we're going to have A pluses and A minuses and B pluses and B minuses and everything like that. You can change that little function and then it'll change it. So let's say if I want to do A, B, and C, I can change this from pass fail and go into my main function or my grade of function, and I will say 90 is going to be an A. $90 is an A. And then I'll put another thing here. Oh, we want to change the grade, sorry. Let's see. Sorry. All right. So now I've changed the entire function here. The main stays the same, but the grade of function is handled differently. So now I hit run, and I'll put in 77 again. Whoa. Did I forget to change? Oh, get out of here. Get out of here. So if it's greater than 90, it's awesome. If it's greater than 80 but less than 90, it's brilliant. Otherwise, it's a C. So here, I'll do a 95 or 98, whatever. All right, but you get the idea. So, so I guess the trick of this one is when you here. Normally, I'd put output A, output B, output C, but if the function has a return value, then the return value is used just like a variable. You can use it just like a variable. I mean, you can if it gave you an integer, you can treat it as an integer. If it's a string, you can do it as a string. Did we have any assignments that use functions? We did, didn't we have one of them? Maybe not. You guys, I mean, the functions are the last thing that you do in 116. Did we do an array? What we use an array? So I guess we can do it. We can do a similar type of thing. Do you guys remember about arrays? Because we didn't really practice them. I just showed you them. So a lot of times you use functions to process arrays because, like you see here, if I have a variable, this variable is n, and let's say I want to print n, I'll print n. I'll just output the value of n. You see how like if I put in 27, it's going to print 27. Like if I run this and I say 27, C27, right? And it prints. This is where it prints the 27. This is where it prints the C. Now, if I go in here, I can't really change n. If I go into this function, if I change if I say score equals, I'll say score equals 0, right? So I use the score to print out the grade, but then at the end I set the score to be 0, or even better yet, I'll set the score to be 0. Up here, I'll set the score equals 99. Now, when I'm in the main function, I'm using n. I'm giving it the value of n, whatever I type in. Let's suppose it's 85. N stays 85 in this function, in this level of the program. So when I go into this function here, then the n is no longer called n, it's called score, and it's treated as a whole nother variable. And when that function ends, it's like dies. It just goes up in smoke. So if I run this thing and I type in 86, it gives me awesome, but the number stays 86, even though in the function I changed it to 90 something. In the function I changed it to 99, and then changed it to 0, but it had no effect. But now let's go to the main, and let's make this an array. This will be an integer array, and I'll have an array size of 1. So it's an array is usually one variable name with a whole bunch of values, but let's just suppose there's only one little cell in there. Now I'm going to, so n is an array, and so I can't say input n, I got to say input n of 0. Why? How many subscripts are allowed in an array?
Array start at 0.
Arrays start at 0, and so if I have an array of size 1, then the maximum subscript I can have is 0. It's whatever the size is minus 1. 1 minus 1 is 0. All right. Now I'll put in here output grade of n, and n, so this is going to be this function grade of, this is going to be a, sorry, this integer score is going to be integer, no, it's not integer. This can absolutely be an array. No, this is return type, sorry, the return type string, parameter edited, integer array, there we go. So now I'm passing an array. So if I give this, so now the array is score, and the array only has one value in it. So I still have to have score sub 0 gets 99, and all this has to be, all this is it's an array. So I have to have the subscript of it. It won't work without a subscript. Usually arrays have more than one, obviously. But here we got score 0, score 0, score 0. They didn't hit the score. I'm not sure you can see this, but I've created an array of score, and then it's the first element of score, the first element of score, the first element of score, the first element of score. So I'm going to enter in 86, but this is going to change it to 99, and then it's going to change it to 0. And then let's go to the main function, and we'll print these all out exactly the same way. Now here I don't pass n of 0, because n sub 0 is an integer. N is an array of integers. So if I have, well, let's suppose if I call this an array, then I would have array sub 0, array sub 1, array sub 2. This is array of size 3. Array sub 0 would be this one. If I have array of size 1, then I only have array sub 0. That's all I've got. I'm just going to show you this property. So let's put in 86. You see, it changed it to 99, then it changed it to 0, and it stayed 0 in the main program. So I guess what I could do, see what I'll do, is I'll put an output of score sub 0 here. So I'll input it and then I'll output it immediately. Then I'll call this function, and inside the function, I will output this score. And I'll output it here too. So it's going to print out 1, 2, 3, 4 times. Oh, sorry, n sub 0 up here. N in the function, and it's score up here. So 86. But so I type in 86. The function changes it to 99. Then the function changes it to 0. And when I print it out in the main thing, it stays 0. So hopefully what you just observed is, if I create a variable in a function that's not an array, the value of the variable doesn't change in the calling function, the main function. But if it is an array, if I change it inside the function, it changes it in the array. So it's called pass by reference, pass by value. That might be too twisty, but we did do sorting in an array, didn't we? No? Let's see what I think let me go get my array example. I'm pretty sure I had it. Yeah, but it's hard to remember all these things. It's possible. Let's see. I've got array. Yeah, I've got array example. Save link as desktop. This goes here. Oh, I can't open it. I got to open it right file. Open. I think this array example actually came from class. I think I posted this. So this one I've declared an integer. I declared an array of integers, and I loop through all of the array elements, and I assign values to them. And then I print it out as a string. Let me show you. So here I'm running the program, and I'm going to say 7. I'm going to create an array of 7 elements. All right, it's going to be -5, 23, 999, and then I'll have a -321, 46, 0, and 19. And so these are the values inside of that array. -5, 23, 999, 320. These are each the boxes, because I decided to have 7. 1, 2, 3, 4, 5, 6, 7 of them. 1, 2, 3, 4, 5, 6, 7. And so each of them would be 0, 1, 2, 3, 4, 5, and 6. Those are the index numbers of the subscripts of the array. So the trick of processing the array is to create a loop and go through each of the elements of the array, incrementing it by whatever the array index is. Array sub 0, array sub 1. Like that. So I got an idea for you. let's suppose, how many of you guys feel comfortable about, here, let me run this thing. Did I run it? Run, yeah, run. I'll do 7 again, and I'll just do 1, 2, 3, oh, sorry. 1, 2, 3, 4, 5, 6, 99. How many of you guys feel comfortable with what's going on right there? We've got one variable is called ARR, and it's got 7 elements inside of it. Now let's suppose I'm going to enter in these numbers. I'm entering in the blue numbers, but what I really want to do is I want to put the square. I'll put the square of the number inside of the cell, not the number. Square of the number. So I put in 2, it enters 4. I put in 6, it enters 36. How am I going to do that? I've input the array element, and now I've got to do what? I want to get the square. That's it. Yep, assign. So assign ARR sub I is going to be ARR sub I times ARR sub I. Whatever I entered in there. So I inputted it. I got it in there. Now I want to assign it times itself and reassign it back into here. So basically, you know, this, you think, well, how can x equal x times x? Well, what the saying is x times x, then put it into x. You know, AR sub I times AR sub I. Do you know about what I'm talking about here? Is this sentence clear? Ish. So here, if I run this thing now, if I say 1, actually I'll say 7 because that's how big the array is going to be. I'll say 1, 2, 3, 4, 5, 6, 7. And it's got the squares of those numbers now. Now let's suppose at the very end, I want to swap the first one and the last one. I want to swap them. I want to put the 49 first and the 1 last. All the other numbers will stay at the same place. How can I do that? This happens at the very end of the program. Before we print out the string. I want to swap. What's the last one? It's ARR of n minus 1, right? That's the last one. So if we want to swap them, I'm just going to use this I variable. I can't. What if I want to just? How about this? What if I want to? What if I want to? Let's suppose I just want to copy the last one to the first one. Just that. Forget about swapping it. How can I copy so that I have 49, 4, 9, 16, 25, 36, 49? How can I do that? Well, so I want to change the value of the very first element. What's the value of the very first element? How do I address it? ARR sub 0, right? ARR sub 0, the first element, and I want to assign the value of the last element. What's the last element? Well, we'll say ARR of n minus 1, so it's no matter what I entered in there. If I entered a 7, it'll be 6, but it'll be whatever I entered in minus 1. So now I'm going to assign whatever value was in the last one, I'm going to assign it to the first one. Okay. I hope I did that. ARR sub 0 gets ARR sub n minus 1. That did not work. No. No, if I should be able to.
Would have to be in the out now.
So I should be able to print out what it is before, then reassign this. That's odd. Gotta be a reason. I'm gonna say output, so that's correct. Let's try ARR of 0. Oh, here I assigned it. Oh, I know why. Because I didn't change the string. That's what it is. So yeah, so sorry. It did work perfectly. I just didn't change the string. So I got to change this, copy output this string, paste, and then that's good. Then it'll work. Wow, man, I was really twisting my arm. Every once in a while, these things happen. Oops. I have to reset the string to be nothing. str gets nothing. Welcome to programming, guys. No, that's how it is. What? 1, 2, 3, 4, 5, 6, 7. Okay, so still didn't do it. Man, that ain't right. String gets this. I'm not sure why that's going like that, but that's the first element. Oh no, yeah, that's right.
Signed it, but it's still giving the error. When you did just.
So here I cleared it. Here I cleared it.
Right.
I'm telling you what, you know what I'm going to do? I'm going to copy this. I'm going to paste it every single time. See what happens. So 1, 1, 4, 1, 4, 9, 1, 4, 9. That's all good. 49, 49. So it does. It prints the last string is the same thing. But I changed this though. It should change that value. Oh, because it doesn't change the string though. That's the problem.
The string is still 1 for.
Right. That's what it is. I'm not changing the string. So what I really need to do is what I really need to do is I need to put an if statement. If I equals n minus 1. If I equals n minus 1, then string 0. Here we go. On the last one, I assigned no, that's not going to change the string though, right? If I equals 0, the first one, on the first one, then ARR of 0 gets ARR of n minus 1. Wow. And then this one. Otherwise, you do this. What this is saying is, I don't need all this. What this is saying is basically check to see if it's the first one. If it's the first one, put the last one in there. Otherwise, post it to the string, right? So we still have to do string gets string plus. It's actually string gets string, gets string, and at space. So if it's the first one, put the last one. Otherwise, put whichever one it is. Oh, the 100% chance this works. No. Hey, no, I didn't know if it was going to, but it's bugs. Whatever. I'm sorry about that, but I guess I don't know how you do need to practice it because it's tricky, even if it's not, even if you have practiced it. How many of you feel comfortable with the array concept? Is it just totally foreign? You don't have to learn it. It's not necessarily required, but I'd like you to. You feel like comfortable with it? How many feel like, yeah, go ahead, put a question on the exam? I was like, screw that, man. Make my life easy. I don't want to see it. All right, forget it. We won't put arrays on there. It's kind of an advanced, but they're coming. The arrays are coming. That's the last. Arrays and functions are the last part of CS116. Yes, sir. Yeah. Yep. So that's pretty much everything we could. Was there anybody who needed to talk about programs today? You need to talk. Okay. Sorry, I didn't leave very much time. We'll call it quits here. But basically, it's going to be data types, if-then statements, loops. Loops with ifs in there, all that stuff, and I think I'm going to skip functions and arrays. You don't necessarily have to know that for 116, but you are going to get into it. So I'm not going to have any final exam questions about functions and arrays. It'll all be loops, if statements, and then data types, modulo operations, things like that. Everything we just talked about today. So if it's not in this video, hey everybody, it's not in this video, it's not going to be in the test. But if I covered it in here, with the exception of arrays and functions, it's going to be on the final. So be prepared for questions for that. If you are going to stay and talk about programs, hang out. Otherwise, I will see you guys. It's today, Wednesday. I'll see you next week. We only have 2 more weeks left. Hey, get your programs in. I see a lot of people are going for the A. Go for it. Get your programs in early and often. All right, I'll stop the recording now.
There's a couple of computers in the back row
Yeah.
that are messed up. They're showing some weird,
Okay.
message. I just thought I'd let you know in case you have to call IT over it.
Okay. Let me just send them an email right now.
Yep.
Thank you.
Yeah, they weren't the one I was using, but I just happened to look over and notice. Why is it saying something about a setup program?
Okay, I will absolutely. Thank you.
Yeah, bro. He helped me with my first, the first 5 hours. Yeah. He helped me with one.
Did you have a question about a program? Let me just make this one quick email to support.
Yeah, he funny though. We see him everywhere now, bro. Yeah.
I'm getting stuck. I don't know how do you get like algorithms like when you enter in a number?
Yeah.
Say I want the user like input 5 numbers, or like the user like inputs 5 numbers. And
Right.
Like,
Do you want them to do like into separate variables? But let me give you. Yeah, I understand what you're talking about. Let me we found new, and so
I'm
here.
trying to do GCDWR, and I got like the equation of like what it needs to be. So like,
Yep, good.
But I don't know how to get the user to input like all the weight that he has.
You can just put input. Don't put any prompt. Just put input whatever the variable is, n. And then their testing program will automatically input it.
Right, so like on the program, it wants them to, it'll tell the user like, okay, input or how many items you have. And so it's the weight of this, the weight of that, and then how many items you have, and then it's entering the weight of each item.
Yep.
So like,
but like, let's suppose
I got like the 3 variables.
Right. It'll say like you get 3 variables. The first one is this, the second one's this, then it'll just be input A, input B, input C.
Oh, like would it? So I guess what I'm asking is like, they'll only get to input the amount of numbers that I say. So how do I get it to be the amount that they say? Like
In a loop. Normally they'll say it's going to be 5. The first number will tell you how many numbers are coming next.
Right.
Is that how it is?
You said the third number. So like,
is yours quick?
Yeah.
What's that? What is it?
What's the name of the decoder that you're showing us at one time? What was the website?
the compiler.
Oh, the compiler?
Yeah,
JDoodle.
JDoodle, that's what.
Sorry about that. Yeah. Sorry about it. If it's quick, then go ahead and fire away. Yeah. And you can also just text me on the MS
So
Teams.
I got the integer GT and.
Yeah, that's perfect.
So I got like this. So I got
GTN, no, brilliant, great. Output G minus T, 10, yeah, great, fabulous.
so I do so that's for
Is that
this for this no, so it should be
You're getting 3 numbers. Oh, you're getting 3 numbers per line.
well for the first line, and then the next line is the.
So you need to put it into a loop, right?
Right. I don't think I really understand like how loops work. Like
They're complicated.
Yeah.
That's why they're the last thing to cover.
Yeah.
I mean, so the idea is so basically you can put like click on one of those lines. Doesn't matter which one.
One of these ones.
Doesn't matter, yeah, one of the ones, and then choose that while.
And then I said I don't even know what like which.
Well, if you know exactly how many there's going to be, then you would pick the for loop.
Okay.
But if it's indefinite, then you just keep on doing it. And so that then you put the inputs in there. Basically, you put the entire program inside the while. You just keep on doing it until it's done.
So
This is GCV. Which number of carrots is that?
I don't know, 16.
16?
Because like I want the last number they input to be the next line of how many numbers they enter in the next one.
Right. And what I think, I'm just going to double check what other people have done. What I did is I did a has next. But let's see. He did. He did R equals 1 to N. What's N? Oh, R equals 1 to N. What is N?
N is the number of items they have.
Oh, there you go. Okay. So that's what your while loop is, 1 to N.
So I guess I was trying to do that while you were doing the loops just to see like if I could figure it out.
But see, he did exactly the same thing you did. He defined his variables, grabbed everything, and then fired off this loop. So everything you've done up to this point is correct. He initialized some zeros. I'm not sure that a lot of times there's a lot of unnecessary code in here.
Yeah.
But whatever it is, but yeah. So this is.
But
So
I guess my thing is like, what do I put in the while loop for it to for him?
Well, it sounds like you need a for loop in this case for 1 to N. If N is the number of lines, then N is the number of loops you need to have.
So when I put in, that's what I was using before.
I'm glad to see that you're doing this. I was worried that you were going to give it a shot.
No,
Because I promise you, this is
I just
really
haven't been seeing it. I've been like going through down like that
Good.
time. I just haven't.
good. Are you going to take 116?
I signed up for it, but I don't know if it's gonna work out with my
What do you, okay, what do you want to do with your life? I mean,
I'm trying to get into cybersecurity.
okay,
So like, I'm trying to get as much experience as I can. So I took a bunch of.
are you going to the cyber thing on Saturday?
It's the same time as our spring game. So I was hoping
Can
somebody
you-
could record the live or something like that. Or I can
man.
record the live on my.
Yeah, it's you can join online, you know.
Yeah. Because I saw that stuff, but so I signed up for a bunch of. I think I'm taking one of yours. And then it's like available, like.
I've got a cybercrime course, but I also have, I don't know what I've got next. So in the fall, there's no way I've got web and I've got mobile computing. Mobile computing is a
I
grad,
think that's what
that's a grad course.
Is it actually?
You can take it if you want to.
I took it just because like I really just need credits. Like it doesn't matter if I pass the class or not. I just need
Why?
credits. Because it's an eligibility thing.
Oh, okay.
Like, because I already graduated, so. all the
Are
stuff
you
I'm
gonna
doing
go
now is
pro or
like-
something?
That's the plan. But like, you never
Are you
know.
that good? Are you that?
I don't like to boast, but.
We don't have that many people. I don't think anybody's gone pro from Saginaw Valley.
Nick McCrary, he was a.
What?
There's a few. There's a few. A lot of them are older, like 1970s, 80s. But there was a guy who was like that 2 years ago.
Okay.
He was with the Browns.
No, we had. I went to college at Princeton, and we never have anybody go pro.
Yeah.
But we had this one guy, Alonzo Bell, and he was in civil engineering with me, and like he was pro.
Yeah.
He was pro, and he looked, but he was about 3 times your
Yeah.
body weight, and maybe a foot taller. And you're tall. You know?
I mean, that's the plan, but obviously.
So what position?
Safety.
Ooh.
Yeah.
Did you see who's the guy in Tampa Bay that came from Central Michigan? He's got a hyphenated last name.
What are you talking about?
Yeah, he's from Flint, I think. He's from my hometown.
Yeah.
Wow, that's pretty cool. Well, so really, you care about football. To be honest with you, it doesn't even matter. Are you gonna try to get a degree? What's your major?
I don't have enough time to do that.
You don't need it.
Nah.
2/3 of the people in our field don't have any degrees at all,
Yeah.
and they're big.
See, like, I'm doing that certificate thing.
But you've got the gray matter to do this kind of work.
Yeah.
I'm not saying, hey, look, someday you're not going to play football.
Right. Yeah. Exactly.
This question with this next year, or it's going to be 10 years from now, but someday, unless you're Tom Brady, it's not going to be 30 years from now. Safety position, I don't think you're going to be able to do it for 30 years. So even if you have 5 good years, you might make a career's worth of money, but you never know. You might want to get back into the field.
Well, that's what I'm saying. Like, I feel like I just need to get. I need something.
Yeah, just
Even
get.
if I don't get it, like this is something I want to do.
These kind of things really tells you the kind of field that you're in. It's a lot of nitpicky bullshit, confusing stuff that once you know it, oh God, it was so easy. But then, but it takes that learning curve.
Yeah.
You can't learn it on your own. You can't go to YouTube. You have to hang out with people.
See, that's like the one that I'm doing. It's a self-paced thing. So like they have like lectures, but like the lectures aren't experienced.
It has to be one-on-one.
Yeah.
It has to be one-on-one.
And that's why
Actually, it's not bad to be like 2 or 3 people teams.
Yeah.
But it's the best thing is to have like one person who's a super expert, one person who's a medium guy, and one that's brand new.
Yeah.
And that actually helps all 3 of them. But unfortunately, that's not the way systems are built up. Yes.
What I do is
So make your loop from 1 to end. That's your ticket.
So that's what I was doing, and what it was doing for me, I guess I don't know if I had the inputs right. So like, I would input, they would put input in, right? Or would,
Yeah, you already got it. You have it. You don't need to input it twice.
okay, so, but I have to assign something here.
Well, let's see. It says here, output a single line containing. Oh, you want to get a single. You're going to put one number, right? So you don't need to output in the loop. Have one output line.
It's been saying that, but I just been doing it. Just 'cause, like, I don't know what to do.
So this
So like, I didn't know how to put like
let's
425, 280, 50 all in that line.
You don't have, you can read them one at a time.
What are all those numbers?
This is just a cycle, like. Example. So it'd be 400 plus 25 plus 20 plus 80.
GCVWR.
Like it'd be super easy if they just said input the total weight of your amount of items. Then like I would just put the output of like the weight I had, but I got this basically the same question for I think it was like
You're looking to buy a new camper, but you're concerned your truck might not be able to safely pull with it. You look at the truck's gross combined vehicle weight rating, but they're down. But wait, you want a bit of wiggle room in case you want to bring in extra items, blah, blah, blah. The total weight of the trailer you want to bring should not exceed 90% of the towing capacity. So the first line contains 3 integers. The second line contains n space-separated integers. Okay, great. So basically, so this one contains 3 integers, and this one contains however many integers are in this number.
right. That's what I'm trying to get.
So here's what you do. You declare this one, and you assign the value. Declare this one, assign the value. This would be input. So declare and then input. Declare input. Declare input, and then loop from 1 equals this, and you grab inputs for all of these. And these are integers, the weight in pounds of the item you want to bring on the trip. Okay? So you basically just need to add all these up.
Right.
So you basically start, this is where I was talking about the loops and putting a counter in there, or in this case, it would be accumulator.
That's what I was trying
A
to-
sum, call it sum, S-U-M. So you start with 0, add 400, add 25, add 200, add 60, add 500. It would be like this. It would be like, so let's suppose we have this, I think it's the ice, item, right?
Yeah.
So here we have a integer, and it's called item.
Yeah.
Item. And so here you'll have 4, I gets 1, 2, n, right?
Yeah.
And then you're going to have input. You'll say basically item is going to be this input box, right? You're going to have this input. I'll even put it like this. Input item. That means get the item.
Right.
And then you're going to say item, or sorry, you're going to say sum gets sum plus item. So you're going to also have to have sum up here. That's how you do it.
Okay.
So this is where the loop comes in. Loop goes down here.
So
You just keep adding them up,
I guess
and at the end you print sum, right?
yeah.
Or output
Or
output the sum.
you have to put it in the equation. But
Or,
yeah.
okay, whatever, output, whatever it is. Or
So
90% or whatever.
when you put in sum, is that something that's like already that's like a program, like not a program, but that's a
It's not a built-in thing, you're making it.
okay.
You're making a variable. You can make as many variables as you want.
Sum. But it's gonna stack on top of every input that they.
If you say sum gets sum plus this, but you have to assign it 0 at first. So here you say sum, up here you'll say sum gets 0, so it starts at 0. 0 plus this item, then you do it again, 0 plus whatever's in there, plus another item, plus another item.
Yeah.
Let me grab these other people. There's more things in there, but
Yeah,
let me
you-
make
I
sure I
think-
got
I
everybody.
think,
I want to give everybody a shot to get the answer. But that gives you some headway, right?
Yeah, no, 100%.
How much time do you have between now and the end of the semester? You like practicing? Are you guys?
Is
this season?
Our game is on the 15th, and then we're done after that. Which is pretty much like the last week and a half of school.
That's pushing. That's putting a lot of pressure on yourself.
Yeah. No, I think I got like 22 points.
I saw. Oh, you haven't got any, but yeah, turn them in.
Yeah.
Don't turn them into all the last week. Don't do that to me.
I'm gonna do
You're killing me.
most of them this weekend just because
I have to go read all these things.
I gotta come in here, you know.
Plus, you want to have time to ask questions too.
Yeah.
So you've got 2 weeks. So you're definitely been waiting. Sorry about that. I'm really sorry. I shouldn't carry that. It's good.
It's only doing the last. But I can't work it out.
Problem is, you multiply those together and add them.
Yeah, so you just, multiply by 2. Multiply by the price. That's true. Price per month.
So the first number is the price, the second number is how many of these pairs you have. 2 times 2 times 3, then 2 times 4 times 5. Let's go back to that. So the price, the number. You're going from 0 to num lots minus 1. By num minus 1. Well, 0 to num. Okay, yeah. Okay, that's fine, it's the same number, it's good. So the initial length is good, and then the area times length, don't you want to do the area is length times width?
I just need reference. I don't know how to get it.
So I would create a new variable called sum, but add them all together, right?
Yeah, multiply.
But you multiply each row, and you add the product. Right? So you need to have a sum. So you've got the product, but you need to add all those products. So you have that. That's a sum product, sum product.
So then you create variables sum.
Yeah, let's create a variable sum, and every time you create a product, you add that product to the sum.
So then what would you put in the expression that sum equals?
So the product is called what? Area.
Area.
Sum is sum plus area. Make sure that sum sets to 0 at the beginning.
And then have it output sum instead of.
Yes, you got it. That's exactly, I was about to say that, but I'm glad that you said it first. The sum, which is the sum of the products. You can call it sum of products.
Okay.
All right, Darcy, did you have one?
Yeah.
Is it quick?
Oh,
Is it complicated? Complicated, okay, hang on then. Lucy, is yours quick or is it complicated? All right, I'm gonna do hers first because I want to give you the time that you deserve. All right. Okay. That's. Hold on to the code. Let me grab my glasses real quick. Let me look at the Java code real quick. Oh, yeah, okay. Good. Wait, you bring it up 1, 0. Was that what you're supposed to do?
Yeah.
There's no is greater than or equal to that. Sorry. Now it has to be greater than or equal to that, and less than or equal to 5556, right? But it has to be, if num is less than or equal to 555, all that, then and less than 556. Right? Or 5, it can be 555, 0000, or 555, 9999. It can't be 556. So the range, so you're right, it was quick. In your case, we only have half of the range. You need to put compound. You got greater than this, but also and it's less than this. That's inside our solution. What I'm talking about?
Yeah.
All right. Make sure this.
Is that a problem?
What's that?
Hard problem?
You going for a hard one?
No.
Okay. But you crush it. You're pumping out code. It's good, right? You feel good?
Yeah, Like I have to spend like 2 days and 2 nights in.
But I think that you're strengthening your mental muscles. You keep up.
Yeah, like I'm like.
I hate reading all the stuff that you're turning in, but I'm glad you're turning it in. So.
I'm out of like only 0.5 points.
I know, but that's actually, you only need to get 0.2 more. Like,
Yeah.
0.2 more point.
I'm programmed here, that's not working, so I think I will get that one. And,
Well, you could also get an A minus. What's the end? Is that the end? Okay, well, whatever you want.
the problem is you can't submit a FRCP file here. In PNG.
Oh, really?
Yeah.
Uh,
We can talk about that.
I can fix that.
Yeah. So the hissing part.
Is he? Yeah.
Yeah.
Yeah. Ben turned it in. Yeah, it was a weird Java thing. It had nothing to do with the code. This code was fine. Yours is probably fine too. Let me just double check the code. Okay, no, this is good. This is good. That's good. So the problem we had was in this b dot equals b dot equals, because C is I want to say C a char or C is a string. But B is a string too. Oh, but you're doing char and char. But it was all dependent on this syntax here. So let's go take a look. It's working, but it's only not making some cases, right?
Yeah, it's so long answer.
So what I would do is that's Java code. Oh, is it? Can you submit to Canvas?
Yeah, you're showing the wrong answer.
Let's see. Log in.
Yeah.
Okay, so second. So let's go back. Go to the problems. Again, the try, but not uncheck the other ones. Check try, but uncheck everything else. Let's go to hissing. We should be able to see submissions.
I don't think so. It's on screen, right? Yeah, so we have labs, he said, video should back. Then you just have.
Wrong answer, it said. Okay, well, this said wrong answer, it's not giving you the right. See, everything down, down. So what I would try is, they have to both be S, right?
Yeah.
So try on line 17, say if C equals S. Try doing that. So C. It would be, is that right? Yeah, okay. It would be C equals S, right? Let's try that. It was something like that. I can't remember what it was. Ben was the fighting it for that long time. Spent a lot of time on it.
No.
Just know it. If you, I promise you, sit it, figure it out. Yeah, Jennifer's doing it now.
Can I zoom another?
Can we do it in my office?
Yeah.
Yeah, let's do it. So there's somebody who told me you're coming after another class. I don't want to be paying for too long. So maybe the calculator here?
I don't know.
Hey, Mike, I'm gonna be in my office.
Right.
If you wanna come by and, do whatever you wanna do, I'll be there. I just, somebody said they couldn't make my other office hours, so I moved over there. All right. Bada boom, bada boom.